Okay, guys, further applications of the cross product. Now we said that the magnitude of the cross product is the area of a parallelogram whose sides are determined by the two vectors in question. So it gave you the four vertices, so let's make sure that this is actually a parallelogram. So we got 5, 2, 0, 2, 6, 1, 2, 4, 7, and 5, 0, 6. And the distance between these two should be -3, 4, 1. Distance between these two, 0, -2, 6. These two is still -3, 4, 1. That's a good sign. And still 0, -2, 6. So it is indeed a parallelogram. So what I need to do is the cross product of those two vectors. It doesn't matter which one I take first, because again, for the magnitude you end up squaring, so it doesn't matter if the signs end up changing. So -3, 4, 1, 0, -2, 6. So we have I times 24 plus 2 plus j times minus j times -18 minus 0 plus k times 6 minus 0. So that's 26i plus 18j plus 6k. So the magnitude of this thing, though, is going to be the square root of 26 squared plus 18 squared plus 6 squared. That's the square root of 676 plus 324 plus 36. Which is the square root of 1036. As a rough value, it's a little bit bigger than 32. Probably about 32.2. You could roughly approximate this. Otherwise, I'm using, an area, make it kind of rectangular-esque. That's not necessary. There are more applications of the cross product. In physics, the cross product can be used to measure torque, which is the moment of force about a point. If the point of application of the force is Q, then the moment of force about P is PQ cross F. The magnitude of the moment measures the tendency of the vector to rotate counterclockwise about an axis. So the vertical force of 50 pounds is applied to the end of a 1-foot lever that is attached to an axle at the origin. Find the moment of force about P when the lever sits at an angle of 60 degrees. So here we have a 60-degree angle. Here's a lever. We're applying a force down on it. We know this is the length of 1. So that means this should be √3/2, and this should be 1/2. And if it's vertical, then the x value should be 0. So that means our lever's vector should be 0 in the x direction, 1/2 in the y direction, and √3/2 in the z direction. The force is applied straight down, so that should be a force of -50 in the z direction. So if we find the cross product of those, we get I times -25 minus 0 minus j times, should be 0, plus k times 0. We should get -25i. But the magnitude of this, since it's two zeros, is just a magnitude Because if you squared this and took the square root, it would just be a magnitude of 25. It's just in the downward direction. Now lastly, for 11.4, we've got the triple scalar product. That is if you have 3 vectors and you need to use this dot cross product hybrid. It's the same as doing a 3x3 matrix. Instead of I, J, and K across the top, though, you will have U's vector components across the top. Now there's a geometric property of the triple scalar product, which is the volume of a parallel pipette with vectors U, V, and W as adjacent edges, is the length there, or is the absolute value, sorry, of the scalar produced by this dot product and cross product. And what is a parallel pipette? It's just a polyhedron whose faces are all parallelograms. So imagine for every relationship between the U and V, it's a parallelogram. Between U and W, it's a parallelogram. Between V and W, it's a parallelogram. So across all like 6 faces of what would be a cube, it's just like all fallen over into parallelograms across every face, which is in the picture here. So find the volume of the parallel pipette shown to the right having the adjacent edges, and it gives you U, V, and W. So all we need to do is put in U. V is just no I, 2J, negative 2K. W is 3, 1, 1. Okay, so what does this mean? So instead of I, J, and K across the top, we have 3. This is now 2 minus negative 2 minus where J was, negative 5, times 0 minus negative 6 plus 1 times 0 minus 6. That is 3 times 4 plus 5 times 6 minus 1 times 6, because I'm pulling the minus out. This is 12 plus 30 minus 6, which is 36, and it's some unit cubed. We don't really know what the unit is, but that's the volume, and that is it for 11.4.